Today's review topic is geometry. There's a lot to review, so I'm just going to highlight some important things. And if we end up needing to review other things as a class, we will. So just fill in what you see me fill in and leave some of the other pieces blank. The first part is a review of some formulas. So you can see that all of these figures up here are all triangles, just different types of triangles. If we're finding the area of any of these types of triangles, we're going to use the formula base times height divided by 2. Doesn't matter which type of triangle we have. For our quadrilaterals, we have 2 parallelograms here and here. So we would basically do base times height for both of those. But this one here on the end is a trapezoid, so we need to treat that one a little differently. Remember, the formula for a trapezoid involves some parentheses. So 1/2 parentheses base 1 plus base 2 times by the height is our formula. Circles, remember, are a big part of 7th grade, so make sure you know all the vocabulary. This part right here that I'm coloring in red, remember, is called our radius. This part here that I'm coloring in blue, remember, is our diameter. You need to know these two formulas for circles: circumference, which is pi times diameter, and area, which is pi times radius squared. Remember, pi stands for 3.14. We most of the time will not use that 22/7. We'll just use 3.14. Now, one classic problem that you see in 7th grade is the area of a semicircle or a half circle. It can be found by finding the area of the whole circle and dividing by 2. So dividing by 2. Right, the middle box here are composite figures, which are basically figures that can be broken into basic shapes. So we'd say that they can be broken down into basic shapes. For example, this one right here, I would find the area of the rectangle by doing length times width, the area of the triangle by doing base times height divided by 2, and then I would add those two areas together. A little different for this middle one because we want the shaded part, so we would need to find the area of the parallelogram, base times height, the area of the circle, which is pi r squared, and then we would need to subtract because we want the areas that are left. So I'm going to put sub there to stand for subtract. This one right here at the end has a rectangle in the middle, so length times width, and then this part right here, half circle, together makes a full circle. So again, that would be pi r squared. And this is an example where we would add them together. So, basic idea is to find the area of the various shapes and then add or subtract, and it's based on what the figure looks like. All right, the last two deal with triangles and angles. So remember, there's some magic numbers in there that you need to remember. So the three angles in a triangle have a sum of 180 degrees. So they give to us 33 and 75. We need x. So all we really have to do is take our 180 and subtract away the other two angles. So if we make it more fancy and make an equation, we would say 33 plus 75 plus x equals 180. So if we take our 180 and subtract away those two angles, our missing angle is going to be 72 degrees. All right, other two important things are complementary and supplementary angles. So remember, we talk about tricks to remember. Complementary makes a corner, which is 90 degrees. Supplementary makes a straight line, and a straight line is 180 degrees. All right, so you can see that you have some angle examples here. So I'm just going to color a little bit to show you an example of each. So these two angles here, DBE and EBF, are complementary. They make a corner 90 degrees. And let me pick out two for supplementary. ABC and CBF are supplementary. They would add to make 180.